to meet you all. Thank you so much. Just to get started, a little bit of introduction about myself. My name is Hassan. I'm a senior engineering manager at Microsoft. I've been in the tech industry for over 21 years now, and one of my passion really is software engineering to basically be able to go out there and pick up an idea from nothing and actually try to turn it into a design and then take that design into a product and then take that product into the market and see how useful it can be. There is some joy in that. There's some joy about, being able to, use technology to materialize something that can be useful for millions of people out there. And that's the most beautiful thing that you can do with your system. Just to, get started here, a lot of engineers come to me, and ask me these questions, like just on the topic of this discussion, a lot of people ask, they say, where do I get started? What's the roadmap? How do I, basically take control of my career and be able to kind of be impactful and helpful for other people? How do I become a successful software engineer? And, for the longest of time, I thought basically accumulating and memorizing newer patterns and newer technologies and, being able to, kind of regurgitate what's out there already in tutorials and books and social media posts would make you a successful engineer. And then I had this realization that, there are patterns in our world, patterns that allow us to understand how certain things work. And if you employ these patterns, into developing software and controlling the technology and the skill sets that you have, that's what's basically going to allow you to become a truly impactful, rather than just successful, but impactful, someone that can actually, provide value as they go. Because if you're just going to rely on just being a successful software engineer, you may not be able to continue to provide that value in the future. You may have gotten lucky once or twice and you said, okay, I was able to build that system or this system and fix this problem or that problem, but you're not really, creating the kind of impact that can actually guarantee longevity for change. And our world needs that kind of change today. Our world needs the kind of engineers that can actually go out there and pick up something, regardless what it is, a certain problem that we have, maybe a disease that we can't find a solution for, and develop systems that can actually help the researchers and medical staff to help fix that problem, or making humanity an interplanetary species through research. Technology there is involved into everything, and I try to keep people's minds and hearts into focused on impact, rather than just a bunch of technologies that you say, well, I'm good at ASP.NET and I'm good at C# and .NET, but what are you going to do with it? What's the next step? That's really what matters. So in terms of roadmap, from a roadmap perspective, the the first thing you need to understand as a software engineer is how to come up with ideas and how to turn these ideas into products and then take these products into the market. And if you understand that pipeline, every other technology or every other tool out there will just be a stepping stone to make that purpose materialize and become a reality. So starting with purposes, models, and simulations, and this is something I really have to say to everybody, because, I feel like, focusing just on the technology and just on the tools is not enough. You have to know why you're using these tools and why you're materializing these tools. So let me just take everybody here to my screen. I'm gonna do a quick check with everybody to see if, sharing the screen is actually working here. There you go. Can you guys see my screen? Sharing
Yes, mate.
Okay, perfect. Okay. So what are we talking about here today? So there are three things that you need to understand before we start talking about technology or anything else out there. These three things, really govern, in that particular order, govern any system that you can build out there. First of all, you need to find the purpose of your system, and then you want to model the characters or the aspects or objects that, develop that system, and then the simulation, right? The simplest thing in the world is when you go and say, well, I have a room like this, the room that I'm in right now, and this room, basically has a bunch of furniture in it. right? And I basically want to develop a system that would allow me, to find the best way to reorder this furniture in a way that's more beneficial to me and the people that will come visit me in this office or in this room. So we built a purpose, and that purpose is, organizing the room sufficiently, making it, optimized, making it in a way that can serve my purposes of being of someone that is using it, or taking advantage of that space. And then the models in this room is me and all the furniture that is in that room, and then the simulation is the organization itself. If you look at every system and every product you're ever going to build in that aspect, you'll then be able to understand, where your software begins and where your software ends. I see a lot of engineers out there that say something to the effect of, well, I know that I can fix a bug, or I know that I can complete a task, right? I know that I can put, two and two together, and people told me to fix that bug, and I fixed that bug, and I'm happy. But then when I ask engineers, like, what is this system doing that you're in, that you're fixing the bug? And he said, I'm not sure. I think it's something about e-commerce, but I don't know, the full picture. Understanding the full picture is just as fundamental to any software engineer that's working in any given system as much as the technology that they're using. So if you like C Sharp or you like .NET, you see how important that is for you to write a program, solve a bug, or detect an issue. Understanding how that system works end to end is just as important. So you're not just pushing code towards fixing something that you don't understand. In fact, understanding that domain, understanding the system that you're working with is even more important than understanding the technology, because you can employ whichever technology you see fit to serve that particular purpose, rather than just working with the technology that just happened to be there to fix that exact same issue. An ultimate entrepreneurial, innovative engineer is someone who knows so many different technologies, and when there is a problem present, they will pick up the technology that best fits that particular problem. Not a one size fit all, or when you're holding a hammer, everything looks like a nail kind of mindset, but rather more diverse mindset that can actually change things for the better and pick up the best axe for the best tree. So once you realize the purposing and modeling and simulation, you realize this is how I need to present every single system I need to work with. Where do we go from here, right? Where do I start? Where do I begin? I have recently released something called the engineering standard, and this standard basically, I'm going to summarize it here for you guys just to understand, what the standard is. I realize that every system out there that you need to build also breaks into three different components. Even in real life, if you see every living being out there, every living being in our universe either has three aspects that are very important. They either depend on something, or they do something, or they provide a value or a service for someone. So this is exposure, right? Every system that you'll see out there has at least, two of these three aspects, if not all of them. Usually it's just all of them. So, we as people, we basically consume, let's say we consume food, right? And we do a function, let's say we work as software engineers, and then we provide value in terms of turning that energy into software that we build, helping our families, helping people, and all that kind of stuff. Every system out there works this way. Anything that's in our universe, we talk about object-oriented programming. We talk about how we learn from existing patterns around the universe. One of the most, obvious patterns that I've ever seen is that you're building your system in a way that, communicates with other systems. The system does something that makes it unique from any other system around it, and then you're exposing these capabilities from that system in any way, shape, or form. If we zoom in a little bit, just to help people kind of understand how that works, I broke those into three components in here. Every system will have what I call a broker. So these are brokers. And then you have services in here. And then you have what I call controllers. So that's a very simple API that you build that basically allows you to expose maybe a RESTful API endpoint, or it doesn't matter what the protocol that you're exposing is, but your simple API, let's say you're working with ASP.NET, API, you're gonna need to break your API into, these three pieces, right? So the governor of all of this is the model that comes through to go through all of these systems. But these brokers basically help you integrate with different systems while abstracting away your core business logic, right? So what's an example of that? Assume that you have a simple student API, students APIs is my students service. This service here provide services where an API endpoint can consume these services by adding or removing or retrieving a student by their ID and all that kind of stuff. But this service is abstracted away with a broker. And this broker is basically, let's say, a storage broker in here, storage broker. And this storage broker basically goes out there and wraps up the dependency, which is a SQL server or whatever the case may be. It can be really anything. So this is your database in here. And then in front of this service, I basically put in here a controller API endpoint that basically handles the requests that are coming from the outside world, like this. It handles requests coming from the outside world. It takes that request going through the student service and basically persisting that information in the database, or retrieving that information into the database. This here is fundamental to being able to build clean, reliable, testable enterprise level software. It grows a little bit bigger from there, but I want to make sure that you kind of burn that image in your memory so you understand how to break your code into smaller pieces and smaller components. Like you'll hear a lot in a solid principle, you hear people say, talk a little bit about, single responsibility. But then what does that really mean? How do you materialize in an enterprise system? This is it right there. You basically pick up, a categorical responsibility. When I say categorical, I basically mean all of it has C# code in it. All of it is doing some capability, but some of it is more abstract than others, and some of it is more core than others. Like this student service in here is exactly what makes your service very unique and independent from any other service out there. It makes your API a lot more unique in terms of the capabilities that it's offering than anything else out there. But then you need integration and you need exposure. And that's basically what, allows other systems to be able to talk to your system through the controllers, but also allows your system to communicate with external resources and external neighboring systems, through integration. Well, what does that come down to in terms of materialization? If you're a .NET developer, there are a few things that you might need to understand to be able to build something as simple as that, right? Like for instance, if I'm communicating with my database, you might need to use something that allows you to communicate with database much more effectively, like an entity framework, for instance, right? Some people like to use Dapper. Some people like to use, there are so many different, some people want to communicate with the database directly with their own code, like a SQL command or whatever, right? It depends on what kind of capability they want to work with, right? So you need these kind of third-party external components that you need to understand as a .NET developer to be able to know how to communicate with external services. External services and external resources don't always have to be databases. They can be another API. It can be another service, like an email service or an SMS service, whatever the need is in your core business logic. But then if you move forward a little bit, comes in the core business logic here. And this core business logic, requires you to understand few things like test-driven development. I personally use something like mock. There's other things like, fluent assertions. You're gonna use some things like, let's say things like, I don't know, object filler, just to generate random information. And then at the top here, you're going to need probably ASP.NET Core if you want to build an API endpoint. So this is an ASP.NET. Maybe you need some external libraries to kind of handle. I usually use something like RESTful Sense, to handle particular responses, in the way I want it to be, since your service is going to be throwing certain exceptions. And then, now you're exposing your information to the outside world. If you want to take that into this is a backend kind of knowledge, but if you want to take that all the way up to the UI, then you want to probably take that exact same model in here, but instead of a controller, you're going to be basically exposing. So you don't have a controller anymore. And instead of that request coming in, you're sending an API broker. So this is not a storage broker anymore. This is an API broker like this. And you don't need EF anymore. You maybe just need something like RESTful Sense or something that calls an API. And instead of a broker, you will need to basically build UI components. And these UI components can be for mobile, it can be for web. I personally use Blazor for the web, just to build something like that. And then here to be able to kind of expose these components through a web page. So you have a bunch of components, and these components are plugged into a page. This is a component here. Component. And then under that component, you basically have what I call a base component. And this base component is basically just the minute of details, the simplest, structure of a UI component that basically allows a system to communicate with, to actually leverage and use a UI control. So see how this map is? Any you don't have to even be a .NET developer, just an engineer in general, someone who wants to build software. If you can follow this pattern or this standard into building your software end to end and understand how to build APIs and then go on the other side and build UI components in this matter, of course, just you understand, a component, one component, you could have multiple components using multiple base components that are being leveraged on multiple pages. A page can never call a base, but it calls a component. And this is all test driven, end to end on both integration and system level. I feel like I threw a lot of stuff at you guys. Does that make any sense? Do you guys understand what I'm talking about? Any questions so far?
Can you explain about that base one? So is the base is actually the result?
No, a base is just simply like, let's say, so let me explain this. Let's say you have a web page, right? And this web page, let's say, has a control in it. So let's say, there's a form in this web page, right? And this page has basically let's say a text box in it. So it has maybe 3 text boxes. So for instance, you have a, first name, middle name, last name, something like that. So you have all of these, and maybe there's a button in here, right? So this is a button that says submit like this. And then you have, I don't know, enter your username or enter your password, maybe something like that, right? So this entire guy here, the encapsulator of all of these components, the encapsulator of all of these controls is what I call a component. So let me put like a little arrow here to point at this and say this here is what I call a component. All right. But the component is just a container of a bunch of controls, right? So each and every one of these controls here, like this button, for instance, is what I call a base component or a base. Why is it a base? Because it doesn't really hold any particular, doesn't form any particular purpose in and of itself, right? It just gives you a control that you can use. It can be a button, it's a reusable control. Like, it can be a button, it can be a picture, it can be a text box, it can be a radio button, it can be whatever. And then comes this big guy here, this guy here. And this guy, this container of components, there could be multiple components in this, on this page. This is what I call a page. And this page here is basically the one that contains all of these components. This is a page. Like your page, for instance, could have like a dashboard, like a toolbar at the top, and this toolbar has your profile. Like, let's say, for instance, you may have your profile up here, and this is your profile picture in here, and maybe you have maybe a, I don't know, a menu or maybe a hamburger menu sitting up here. All of these are different components that has their own kind of base components within them, and then you have this particular component that serves a particular purpose, right? So if you look at that in the bigger scheme of things, if this component here is sitting in here, this component is the one that's really sending you the login, username, and password through your services. So it goes through your service sends it to the API sends it to the controller takes it and tries to validate that login and username for the user, for instance, right? Whatever the business case may be. So this component is using text box base, button base, maybe label base, building that registration or login component, and then displaying it on the screen just like I did like right here. Does that does that clarify things a little bit?
Yeah, mate.
Okay, so once you start building these things, now you want to know a few things. Like you want to be able to kind of, take that stuff to the next level, right? Like let's say, okay, I built this amazing system out there, right? And I learned about all of these little components. Now, how do I take that to the next level? Just before I move on from this piece, I want to show people here a very important link. If you go online and search for, I'm gonna unshare and reshare here. Let's see. Yeah, so if you just type the standard like this, just type my name there. It'll take you to this GitHub page. We also have a great Discord community. It almost has 14 people online at this hour, but it has almost 100 individuals that are, building their software according to the standard from all over the world, right? This standard basically explains to the last detail, every single detail you can possibly think of, everything single step you need to do to basically build an enterprise level system. I'm not writing a standard for people to go brag and say, oh, look, I know this or that. I'm building it so you can come up with an innovative idea and you can confidently turn that idea into something worth its while so you can actually, benefit yourself and benefit the world in some way, shape, or form. It has a lot of details in it. And then there's the community where you can ask any questions you may have. But it'll be very helpful for you to actually learn that standard and know how to build things. I believe learning how to architect software at a low level, according to this standard is even more important than learning any technology. Like I think it precedes, learning any technology, no matter what this technology is, because eventually the technology that you're using to build a system, eventually that technology will become obsolete, right? Like people just not too long ago, people were so happy with, Fortran, right? They were very happy with COBOL, right? And then it went down and Java took over and then another language came over and so on and so forth. So, you know, don't get too attached to technology, understand how to build systems, and then out of these systems, go ahead and use whatever technology fits you. It just so happens that at this day and age where we are right now, I couldn't find anything better than the .NET ecosystem and C# to actually build systems like these. It's a very simple language that will allow you to build things on, virtually every other system you can imagine, like from embedded systems all the way up to mobile applications, web application, desktop applications. But what's more important than this is that we're just using it to kind of materialize some ideas and see if we can build something beneficial for people, right? And if you do that, that's the core aspect of this. But okay, you built a system. Just because you're writing a good system and you can architect a good system, that doesn't mean that you're done here. There's a little bit more than that. So let's go back to our simple system that we built here. Let's just continue that journey together, right? So this is the system that we built together. Right? We built this whole system. It has a database. It has an integration. The system sends a request, and now you can see things. I'm gonna take that API here for a second. I'm gonna tell you what we're gonna do with it here. Let me take that API here. So now that you have this API, it's functional, great API. It's test driven and all that kind of stuff. Now you need to understand something important. You need to actually know how to manage your API in terms of source control, deployment, continuous integration, continuous deployment. How are you going to do that, right? So I'm always a big fan of trying to improve the engineering experience. Like, don't waste your time learning 50 technologies just to do something that you can do with one, right? I've seen a lot of people, go and say, well, we need to learn a language like YAML, and we need to learn ARM templates, and we need to learn all of these different other technologies and languages, so we are able to actually make deployments and make integrations and all that. So just so you understand, your code is going to go from this, assume that this is your code, it will go into this stage where it needs to be source controlled, right? You can be using GitHub, you can be using Azure DevOps, you can be using whatever else is out there, doesn't matter. So this is your source code in here, source control. And then out of source control, you need another stage where you start building and running the tests on your code. So there's the build and test in here, build and test. So these are your pipelines. Out of your pipeline, there's another stage where you want to go and say, well, I need to deploy, right? So I need to take that code that I just built, these binaries, and I need to release, that code. Now, releasing isn't really that simple. There's a prerequisite to this release, and I'm going to put that prerequisite here that it may or may not be needed depending on whether you have the environment running or not. And this prerequisite is provisioning your resources, right? And it depending on whether, so I'm going to put it here in a light. It depends on whether you have your resources actually living, breathing in the cloud or not. That's how you determine whether you can release or not. So this step is mandatory, a prerequisite to this step, right? So you're pushing it to source control, you're putting it in you're putting it in build and test. You go ahead and prepare a little bit, you're provisioning your environment, and now you're pushing your code all the way out there. And when you release your code, now everybody can use it, right? It's out there. If it's a website, it's out there, everybody can use it. If it's a simple system, maybe it's a mobile app, you're deploying it to the Google Play or Apple Store, whatever the case may be. Now your code is living, breathing out there. You see how the journey here, your journey started from, a little bit even before that, started from an idea in here, and then you turned that idea into design, and then you took that design and you built a system out of it like this, and now you can take that system all the way up to release stage where you're putting it out there for people to use. What's after release? It goes one little step further than this, which is what I call the market, right? So you're taking that and you're putting your software out there for everybody to use, and now you're learning, you're getting feedback. Now watch what's going to happen here. So this is the market. Okay, so you released it and people are starting to use it. What happens after you release it and people start to use it? You're going to go full circle like this all the way back to here, all the way back to the ideation process, and you start learning about your system. Maybe people didn't like it. Maybe there's a broken feature. Maybe there's maybe there's a feature that can be a lot more beneficial to this. So you go all the way from the market back to the idea where you need to redesign a solution for a system, design a new feature, design a new capability, and so on and so forth. So you're going all the way back to an idea, back to a design, into the development, push back to source control, build and test, provision, release, and market. That's a full life cycle of what you're trying to accomplish as an engineer. This is the end-to-end kind of capability that I want every engineer out there to be able to, see and understand, because that's the only way you can actually, actually make a true impact in the software market, today. Okay. So this is all one full cycle. Sometimes the market will push back on the release and say, well, this feature is broken. Let's roll back into version, maybe you released version 2.0. They want you to roll back to version 1.0 because 2.0 has proven itself to be broken. Sometimes it goes back like this, right? Sometimes the release we'll have some issues, so we need to re-provision. Sometimes the provisioning will fail, so we'll go back to the build and test and so on and so forth. Sometimes you'll get feedback on your pull request from your peers on source control, so you need to go back to the development stage, right? And then from the development stage, maybe the feature is not right in the first place, go back to the design or come back with new ideas. So you see how the interactivity in our software, this is truly the full life cycle of software development. And these are the things that you need to do. Now, some people would say, well, how do I do this? Build and test and provision. I developed some libraries and some practices around most of this. So source control, like these days, I use GitHub. I like GitHub a lot. It works fine for me these days. So you can use GitHub for now. So it's GitHub, but you can also use other things like GitLab or, Azure DevOps, whatever the case may be. In build and action, I use something called GitHub Actions, right? So it goes and picks up actions for me and basically gets them done, right? In provision, I use Azure APIs. I'll show you some of these examples right now. Azure APIs, right? In the release, I still use GitHub Actions as well. I'm actually about to record a session with a friend of mine and into the releasing. And then the market, it depends really where you're pushing, right? It could be either the World Wide Web, if you're pushing a web application, or store, an app store, whatever the case may be. So these are my tools here, right? And then you go back into, I mean, for design, you use your brain mainly, but I personally use this very tool that you guys are looking at right now, which is draw.io. It helps me a lot, kind of visualize my ideas, and you might have noticed I'm very comfortable with it, right? And as you go here, you're basically using all these tools that we talked about, like C#, ASP.NET, mock components, whatever the case may be, whatever works for you and your team, right? So this is the life cycle here. And if you don't, I need every engineer out there. Listen, a lot of people say, well, I'm a programmer. Why do I care about some DevOps operations, all that? Don't think this way, because if you really want to take your skill set, you want to take your craft to the next level, you have to really be aware of these things. You have to really understand how to do these things. Don't just, I see a lot of engineers stick into the business logic and say, I'm a programmer. I only do business logic, right? And they have no idea what's going on around them, right? How can you possibly grow as an engineer, right? If you are not learning about, your system end to end. So in the future, you can lead other engineers and lead other teams and be able to kind of bring about a true value, stay connected to the market, but also at the same time, very rooted into technologies that you can actually develop systems that can make that kind of impact. So this is the end-to-end kind of thing. You'll see a lot of materials online that I pushed on YouTube. You'll see these materials on GitHub. Now some people might come to me and they say, okay, well, you're talking about this theory, but what does this theory look like in reality? And the answer to that will be, so I have really so many different open source projects that can actually show you, what an end-to-end system might look like. For instance, you can have this open source schooling system, has over 5,317 commits, so many different contributors, 52 contributors from everywhere around the world. And I will show you exactly the same structure. Here's the provision, here's the build, here's running acceptance tests, unit tests, and here's your API. And your API, of course, as you may have guessed, it has brokers, controllers, and services right here. And every service has its own model, many services, as you can see here. And each one of them has its own way of handling its own business logic. There's the noise cancellation for exceptions. There is the way that, so you see this service is doing a lot of stuff, yet it doesn't exceed 70 lines of code. How did that happen, right? Are we really doing everything? Yes, we're doing our validations. We're leveraging partial classes to be able to encapsulate our validations using, a sort of a business rules engine to kind of validate our rules and put them in a report. In the exceptions area, we're using the exception noise cancellation, so we can handle all the exception in one single file away from our own business logic, and then reuse that as a monadic function that can actually go through and actually handle our logic there. So that's basically the high level, right? You need to start from an idea to understand how an idea, how do you form an idea, something that's bothering you personally, or if you're helping with a certain project, you need to understand what the core idea is so you can innovate, right? Software engineers are not coders. They're not just people that write code, but rather people that think through a problem and use code to express their solutions to these problems. And keep that in mind, because if you're just writing code, eventually your job will be automated, right? We have already today things that can write code for us automatically and generate code and all that, right? But that mindset, the solution that you can come up with and then express that solution through code, it's going to take a little while. It's going to take a lot while for people to kind of come up with something that can kind of compete with that, especially with the, infinite number of variables and variety of problems that are out there. It's going to take quite a bit to kind of find an AI system that can kind of replace that if we're not talking about singularity. So that's pretty much it. I don't know, do you guys have any questions, any concerns, anything at all? Does that, I'm pretty sure you might have some questions. You might have a little bit of, maybe some of the things I said a little bit confusing. Is everything clear?
Yeah, Matt, so we can do a QA session now. So I have given the permission to unmute. So if anyone has the question, then you can ask to Hassan.
All
Uh,
right.
yeah.
Any questions at all? You can unmute yourself. Right. Okay, Jay, it's crystal clear.
Yeah, seems like that only.
All right.
Yeah,
Awesome.
it's the best explanation I ever got. Thank you.
Awesome.
It helps tremendous. Because
Awesome.
I'll write you an email because I have an idea and I have no idea how to come from that idea to at least to a product or to something which helps others. So I will contact you separately.
Absolutely. And
Oh, that's
I'll
fine.
yeah, and I'll post my address here for anybody else who wants to kind of, reach out to me. It's Hassan Habib at live.com. Feel free to reach out. The most important thing that I just want people to understand is that, find your genuine idea. Everyone out there in the world today has a genuine idea, something as impactful and as effective as electricity. See how electricity changed all of us, changed our lives forever, right? Every one of us has an idea that can change the world as aggressively as electricity. We just need to kind of look within and find that idea. And then, people like myself will be more than happy to kind of bring about the kind of the kind of tooling and the kind of guidance that you need to actually make that idea turn into a reality, right? Like the tooling, anybody can use that, right? But from an ideation standpoint, that's where our ourselves as human beings actually find ourselves very unique from anything else around us. I see I see a question here from Ashmita Powdell. For beginner, what do you suggest first learn to get into .NET? How to engage in one language for long term? Well, if you want to learn the .NET, I personally, recommend just starting to the best thing, if you want to learn a certain programming language for starters, like C Sharp, for instance, um, try the practice of saying a sentence, any sentence, and see how you can reflect that as code in C Sharp. Whatever that sentence may be, this is how you're training your brain to translate ideas into code, right? And once you figure out C Sharp, so you want to focus on C Sharp, there's a very big series that I have on my YouTube channel called Learning C Sharp with Sally. I really highly recommend. It's about 20 videos. It's a list of 20 videos. Highly recommend watching that series to kind of get going and get started with C Sharp and .NET. If you want to get started there, let me kind of try and share my screen here just to show people where to find that series. So if you go on YouTube and then you go on to my channel, Jay, would you mind sharing the link to my channel? Here it is. I have it right here. So here's a link. So this is the channel, and then if you go into the list, a lot of people, don't know about the list. If you go into Learning C# with Sally, this series here is about 20 videos. It'll take you through the journey from nothing. You don't have to have any background. There's no prerequisites here whatsoever, right? It's literally telling you learn something from nothing. When I worked with Sally, she basically had absolutely no background whatsoever about programming or C# or any of that. Start from there, and then from there, start working on reading the engineering standard. Learn about integration. How do I integrate my system with another system? And then how do I add a little bit of business logic on top of it? And then how do I expose this capability through a controller, an API endpoint, or a UI component, or whatever the case may be? If you do that, it'll make it a lot easier for you to basically go and actually build systems. This is the path I would choose for people to start with, which is a path I would have loved to start with when I was a little bit younger. When I starting this, I had to kind of get lost for a while to kind of figure out what do I want to do and what I want to be. And then I ended up with the standard, building an engineering standard to kind of clarify the way. So definitely start from learning C#. You can use this series, Learning C# with Sally, and then start working on the building blocks of the engineering standard: brokers, services, foundation services, and then you work on API endpoints, maybe UI components, API integration, step by step like that. It's a recipe for you to build components, and in the midst of it, you are learning how to build systems, but also getting used to the language and where to use a particular capability versus another. Definitely start from there and work your way up. See, so I'm not even talking about a particular technology. I'm just telling you here, learn how to build these components, and then find the technologies that you need that will help you get these components done. I can guarantee for everybody in this channel and everybody who will be watching us, if you go through this standard, the engineering standard, and read through it and try to understand it, you will learn potentially most of the things that you're looking for: test-driven development, dependency injection, solid principles, learning C# in the process, ideation, simulation, modeling, exposure, all the way from API controls to protocols to UI components and web applications, and all the way through the release process of your software. So definitely that's a good place to start. Thanks for asking, Shmita.
Thank you, mate. So I have one question about for the student. So as I am also the .NET developer, right, and I'm seeing lots of changes there. Just like before, I was in ASP.NET Core, then after MVC, then after .NET Core 2.1, 3.1, .NET 5.
Mm-hmm.
Now .NET 6 is the latest one. So for
Mm-hmm.
the student, means which version they should start, or what framework they should start, or they should start with a new one or with the old one. So means lots of confusion is there on the .NET side. So how do you suggest for the student?
So especially with technology, stay with the latest and greatest, because why would I invest, like, 6 months, maybe a year of my life learning a framework that is already sunset? If Microsoft is saying we're done with .NET 3.5 or .NET 5, why would I go learn something like that, given that there is another platform or another version that's about to go further? Um, Definitely learn the latest and greatest. Don't even worry about the idea of ASP.NET or .NET 6 or 5 or any of that. Just first start by trying to find out, what are you trying to do? What are you trying to accomplish? Are you building? Because the only way you're going to learn is if you find something you're excited about and you try to take that something and turn it into a reality, right? Unless you get to that, like, don't learn technology for technology. That's not beneficial, right? Come up with an idea and try to turn that idea into reality. And in that process, you're going to learn about ASP.NET Core and entity framework, mock and test-driven development, because you need these things to get to that goal where you're headed. So just to answer your question, Jay, it's definitely learn the latest and greatest, always stay up to date, right? I just went out there yesterday and updated all my projects to 6.101, which is basically the latest and greatest release of the .NET framework. Looks like Klaus here has a question though. Can you try to convince MS to do their samples and more important templates to use your standard? We definitely, there's a lot of work to do for us, in terms of standardization and documentation. We'll see what can be done. I mean, there's a lot of smart people at Microsoft, a lot of people that have a lot of great ideas, and instead of just waiting for the IDE or Visual Studio to create a template according to a particular standard, you mold it the way you want it to mold, right? Not everybody out there is going to be following the standard, and not everybody out there has the same standard. Some people has different standards. Some people like to put their logic in the controller. Like I've seen this a lot. I've seen people put their business logic in the controller itself, and some people put the business logic in the model. People like, domain-driven design. They might end up determining that, if I want something to work, I'm going to put all my business logic in the model, because the MVC mindset doesn't allow me to put my business logic anywhere. I threw that MVC model away and I said, okay, let me evolve it. Let me take it a little bit higher and let me say, no, there's brokers and services and controllers and models, and these models are the ones that kind of control, what kind of contract these different components are going to be using to talk to each other, right? So the same thing with Blazor. If you want to look at, a real life Blazor system that's running end to end, I highly recommend looking at something like this. This is going to give you a great idea about. Let's go here. So if you go into OSSS, there's OSSS, the API, and then there's OSSS, the portal. And in that portal, you'll see the web component, and in the web component, there are views, and under the views, you have pages, component, bases. That's exactly what I was just talking about, just shortly. And if you go into these bases, you'll see there's a button base, card base, date time picker base. There's a grid, there's a label, there's a text box, there's all these little, and then there's a validation summary. You'll see all these little pieces basically that, gives you, the bare metal, controls that allows you to do something. And then if you go up a little bit, you'll see student registration component. That's the component that you'll see. If I go into the UI here a little bit, you'll see it's using all these base components. It's putting a text box together, putting a label, putting a date time picker, putting a button, designing your entire component. And then if you go a little bit higher, you'll find the pages. And under these pages, you'll see the, basically how we're leveraging that student registration component as part of our overall design, right? So you mold it the way you want. Don't, like I've seen some folks, like basically one of the things that a lot of people reach out to me recently about is the new model for .NET 6, the new template, which doesn't have startup CS. It has only program CS, and it doesn't have namespace in it. I say, well, whatever makes you comfortable, right? This is just a template, right? But you can change this template to whatever you want, however you want, right? So that's definitely the route I would go. And we definitely need to do more in terms of documentation, basically help people build better systems for sure. Any other questions?
Yes, seems there is no more question. So we
All
have
right.
more for 10 minutes time to wrap up the session. So please continue.
Okay, so just just to kind of wrap up just for everybody here. So the the most important thing, like our technology today is engaged in so many different aspects of our lives, right? From the second we wake up in the morning all the way until we are asleep, and while we're asleep, technology is still doing things for us. If you're wearing a smartwatch, it's measuring your heartbeats. It's basically trying to give you a little bit more statistics and analysis about your body temperature, how comfortable are you in your sleep. You wake up in the morning, you go into a gas station, there's already a digital monitor, depends on, what part of town you're in and all that. And, it's all running through, maybe you're using your watch to make watch you making the payment. there's smart cars now that have systems within them. Technology is everywhere, right? And it's starting to get into further and further fields, right? There's now the metaverse, virtual reality, mixed reality, augmented reality. Technology is spreading really fast, and it can be a good thing and it can be a bad thing. What's more important than actually learning how to, hone this technology and be able to control it is to have a good purpose behind what we build, right? And having a good purpose behind what we build is the only way we can actually create useful technologies for the rest of the world. If you understand the idea of coming up with an idea, productizing it, and taking it to the market, and going back on the feedback and loop back, then the most important thing for you as an engineer today is to come up with that genuine idea, come up with something that can actually be useful for you personally, and then for the rest of the world. Inevitably, there's a lot of harmful applications out there. There's a lot of hackers. There are a lot of people that are trying to make the world a worse place. Use that technology and use that knowledge and use the standardization and your ability to build systems to build something useful, right? And if you do that, you're going to start learning as you go, because once you hit the market, it doesn't matter how crappy your application is. You could be building like a really, you know, half-baked application. Maybe you're missing a couple of tests here or there. Maybe you're not using logging and monitoring, but you made it. You hit the market, right? As soon as you hit the market with your applications and people start using your system, you're gonna get a quick feedback, right? There's one more thing here I want to show people just to understand. I want to show people a simple system that I built. It's a pet project of mine. And this project will basically help you kind of know where you stand, right? Let's say you really want to learn the standard and you want to learn all these different things. How do you measure your, um, your performance, right? So I built this system here to help engineers everywhere know how to, where to start and where they're supposed to head. It basically gives you open opportunities. Like, let's say there's an opportunity here on this project that you can go right now on an open source project. This opportunity will allow you to kind of, building a foundation service that retrieves all courses using an API, right? If you take that and you go finalize this task or whatever the tasks are available, maybe there's almost 220 of them right now. It will add up. So it will take your code and turn it into a resume for you. So you don't have to write your own resume. This system basically will take your code and does the marketing for you, right? Marketing for you about your own code. All you have to do is really write the code and it'll go and say, where do you rank? We have a leaderboard in here that tells us who's the highest contributors, worldwide across all standard compliant projects. And because of these contributors, you can actually find a lot of mentors out there that will help you walk you through the standard and be able to understand how to build systems. But more importantly, it'll also help you understand where your area of focus is when you're building software. Are you building provisioning components? Are you doing code drops, code cleanup? Are you doing configurations? Maybe pushing minor fixes or pages or acceptance tests, all the different kind of capabilities. Like if you go into our about section in here, I broke down all the activities that an engineer may need, to build a simple system, starting from an infrastructure component all the way down to management, exposures, base, pages, acceptance, minor, major, medium fixes, preview, standard design, and business, right? So this system here, GitFyle.com, is one of my passion projects, something that I'm building on the side. And it's already public and available and ready to run. All you gotta do is to go find a standard compliant project, like one of those opportunities that are available in here. And it'll basically, give you the chance to start building your portfolio. I also said, like, if you have opportunities in here that you want to work on, I'm gonna give you code examples so you know how to finish this task. I'm gonna give you it will point you to a chapter in the engineering standard that will show you, the theory behind what needs to be done. And I will even give you a YouTube video that basically shows you exactly a similar task that I've done with another person, where I am pairing with them and showing them how to get it done. And if you run out of all of these options, like none of these options are useful for you and you're not still confused what needs to be done here, you can always click on that question mark, which will take you straight to my LinkedIn page so you can ask me any questions you want. But once you're ready, so these are 4 different ways you can learn because people learn differently. Once you're ready, you can just click go and it'll take you to this task where you can actually start working on it and start changing it and start contributing to it. So when you learn the engineering standard, you're not just learning an engineering standard. I built this system for myself and for people like you and for everybody else around the world to be able to measure their performances. How many days have you been contributing? What's your grade? How much percentage of your effort, are you actually pairing? How many projects have you worked on? What's your rank? What's your level? Like on the level side, you'll see something interesting. Like you'll see a lot of people kind of throw around words like developer, engineer, programmer. I tried to put all of that into perspective and I said, okay, here's a coder and what a coder does. Here's a programmer and that's what a programmer does. Developer, engineer, innovative engineer, entrepreneurial engineers, and then the EIEs, which are the entrepreneurial innovative engineers. Each one of these have some requirements, and the more you finish more tasks, the more you're building this portfolio for yourself. Definitely highly recommend people go and check out GitFile and see the amazing capabilities, that it can offer you to kind of keep track and measure your performance. There are so many open opportunities out there that you can take advantage of. But also at the same time, it keeps track of all your contribution throughout the years. So you know whether your last contribution have actually been accounted for or not. Like this is, for instance, a task I just pushed yesterday to upgrade the .NET version back to Jay's question from 6.0.100 to 6.0.101. So systems like these are built for people who want to bring, their careers into clarity, into perspective. If you're just learning about this for the first time and you never built any code before or did anything like that, that's exactly the perfect place for you to start because it won't just teach you the technology, it'll actually help you learn how these technologies work and all that kind of stuff. All right.
Can you share the link on the channel?
Oh yeah, it's GitFile.com. Yeah, absolutely. So there's this. All right.
Yeah, thank you, mate. So
Awesome.
the last one is, so you have talk more about the architecture point of view, means how to make an idea, then after reflect to a design, then after follow some flow, then push to the build and push to the market. So beside that, what are other roadmap that the .NET developer should follow, not in 2022, but more over on the career point of view? And this
Yeah,
related to the professional person also.
yeah. From a career standpoint, now that everybody needs software engineers, if you're gonna end up like, looking for a job and getting a job, work somewhere you're passionate about, right? You'll find a lot of opportunities available, but just because an opportunity is available, it doesn't mean that it's, the best option for you, right? Like I see a lot of people, end up in places where, they're not necessarily passionate about the topic, but they'll tell you, well, it pays my bills, right? Okay, let's say you had a financial situation and you need to be able to pay your bills. That's great. Go in there and kind of find the financial stability, but don't stay there all your life. Like when I see someone staying in the same place for 20 years, 25 years, doing something they're not really excited about, and they're just telling you this is just a job. That's the worst thing you can do to yourself, right? If you're planning to find a career and start a job, find a field that you're excited about. For instance, let's say some people are super excited about robotics, right? Like some people like AI, some people like, web development, some people like commerce, whatever the aspect is that you like, make sure that you align your daily job with your passion. The worst thing you can do to yourself from a professional growth perspective is that you have your career going like this and your passion going in a completely different direction. Like I see a lot of people are super passionate about IoT, Internet of Things, but their day job is, for instance, into, some e-commerce or, some, office applications or editing or whatever the case may be. That's not a good alignment, right? You want to align that passion of yours to IoT or AI with your day job so you can actually skyrocket and your growth, can happen as fast and as soon as possible. So make reasonable decisions when you are deciding to pick up a career. Go after something you're really excited about. If you have to go somewhere temporarily just to pay the bills, that's fine. But don't just stop there. A lot of people just settle there and they say, well, I stopped trying, right? I stopped trying, I started investing. Especially when engineers spend a little bit longer in one place or another, they get into managerial and leadership position and they stop writing code and they stop engineering. So their, you know, overall value becomes really minimal because they can't even build systems anymore. They are very detached from technology. So how are they supposed to, be able to lead engineers that are speaking a completely different language for the day and age that they're in? That's my most important advice. Align your passion with what you're looking for, right? Build a skill set. Like for everybody in this channel, if you build a skill set to build systems end to end, finding a job or a good career is not going to be a problem because you're an end-to-end solution guy. You're an architect, you're an entrepreneur, you can build systems end to end. It's not as complex as some people may think. Like if you focus on some of the content that I put on YouTube, if you just lock yourself into that content for like a couple of months, you'll be just fine. You'll be able to build your own systems, develop your own. The reason why I tell people follow your passion and develop your own systems is because that's the only way you're going to feed yourself all of that plethora of information without having to worry about how much more is left because you're chasing something else. You're chasing a goal that you're trying to accomplish. So it's exactly the same way there, right? You want to be able to like just build that skill set, take a couple of months, build that skill set, and then go out there after a job or a career that you are passionate about. What do you want to do? Most of these things starts with you. It doesn't start with what's available out there. It starts with you. Like if you take Elon Musk as an instance, he one of the things that he says is that he technically got rejected or he couldn't find a job in any of the internet companies that were out there. So he started his own, right? He said, well, I couldn't get a job in any of these internet companies, so I'm just going to start my own. Once you find your purpose and your passion, it doesn't really matter what's available because you will make what you want available for yourself. And that's where I want people to kind of start in terms of careers.
Okay, thank you, mate. It was most motivated. Awesome, mate,
Awesome.
for your wonderful presentation. So I hope all the attendee has got some new information about your presentation, whatever you have talked on today's Tech Webinar Series 39. And thank you for invitation. So especially because I watch lots of your YouTube video. You speak on different technical topics, and I hope that the attendee will also go to your YouTube channel and get lots of information from that. So with this, I like to thanks to our supporters, Microsoft, Blink Venture, and media partner Living with ICT. And thank you all for being the presence on today's webinar. And I hope in the upcoming webinar also you will participate as much as you can. And thank you, awesome mate. And I would like to request, if all things is well, means in this pandemic, please visit to Nepal. Might be on
Absolutely.
2024 or
Yeah.
2025. Please, yeah, it is very beautiful country, Nepal.
Yeah, I'd love to.
Visit here, and I especially invite you on that one. And thank you all. Have a nice day. Thank you. See you again. Bye.
Thank you guys. Bye.